Okay, so today we're going to continue with section 13.1. In the last lesson, we learned about the two-sample confidence interval, and this lesson will be about the two-sample t-test. And it's going to be similar to what you learned in chapter 12, the one-sample t-test. But just to remind you, you're going to have two of everything. So for example, we're going to have two sample sizes, two means, and two standard deviations. And then the way that you write your null and alternative will be one of these three methods, depending on the wording of the problem. So you just have to read it carefully. If it says, is there a difference between one and the other, you would use this one. If it said, is the first one higher than the second one, it'll be this one. And if it would say, is the first one lower than the second one, or reduce, decrease, this could be things like increase, higher, greater. So just read the problem carefully so that you can pick one of these. And we're still going to use phantom, so you can review that if you forgot what it is. And then just a reminder, get the degrees of freedom from the calculator. Okay, so if you turn your paper over, here is the formula that we will be using for the two-sample t-test. So it's x bar 1 minus x bar 2 divided by the square root, and everything underneath here goes under the square root. And then degrees of freedom you'll just get from the calculator. Okay, so we'll look at an example from your textbook. If you want to open your textbook to page 783. Okay, so this problem is examining a study, and they want to know if increasing calcium in the diet will reduce blood pressure. So they did a control study in which they got 10 men to be in one group, and they took calcium, and then 11 men in the other group took a placebo. So just a reminder, in a two-sample t-test, our sample sizes do not have to be the same. So here we have 10 and here we have 11, and that's okay. They don't have to be identical. Okay, so it says that they took calcium, these took placebo, and you recorded the decrease in their systolic blood pressure. Okay, so these numbers here, it's not that that was a blood pressure, that is the decrease. So if you have a positive number, it means that the blood pressure did decrease. And if you have a negative number, it means that the blood pressure increased. So this one's the opposite, just keep that in mind. Here you have a summary of the findings for both, and they give you n, the sample size, x bar, the mean for each one, and then s, the standard deviation. Okay, so we're going to use that data and we're going to do a two-sample t-test. So just like before, you start off with phantom. Okay, so phantom is, the P stands for describe the population parameter. Okay, so I'll send you a copy of these notes, and then we'll start describing P. Okay, so P in this case is mu, but remember now we have two of each, so I'm going to describe both. Okay, so we have mu sub C and mu sub P. C stands for calcium and P for placebo. So mu sub C and mu sub P are the average decrease in blood pressure with the calcium and the placebo. And then just say respectively. So the first one is for the calcium, the second one is for the placebo. And then your H is the way that you write your hypotheses. And that's where I told you you're going to pick one of these three. And how do you know which one? It depends on what the question's asking. So if we go back to the problem, the question is saying, where did they write it? Okay, right here. Does increasing the amount of calcium in our diet reduce blood pressure? Okay, and then just a reminder, reduce or a decrease is shown as a positive number, and an increase is shown as a negative number. So we're interested to see if there was a decrease or a reduction in blood pressure. So because that's what they're asking, you're going to write it like this. Okay, so the null is always equals. One equals the other. The only one that changes is the alternative. So because a decrease is shown as a positive number, we're going to put greater than. So mu sub c greater than mu sub p means that the calcium does reduce blood pressure. Because if you put less than, it means that it increases blood pressure. And if you go back to the problem, it tells you an increase appears as a negative response. So we're interested in a decrease, so we write it as a positive, greater than. The sentence is optional, so if you just want to write this, you could, or you can put the sentence. Remember, the null is usually the one that has the word not, so calcium does not reduce blood pressure would be the null, and the opposite, that calcium does reduce blood pressure, will be the alternative. Okay, so this is the P, the H, and phantom, and then the A is for your assumptions, which are the same ones, SRS, normality, and dependence. So for random, because it's a study, you can't choose random people to give them a pill. So the people that volunteered, you randomly put them in the placebo group or the calcium group. So the subjects are randomly assigned. Because we have very small sample sizes, do a graph. So you can enter your data in L1 and L2. You can do a histogram or box plot. So they're not really skewed. We'll say there's no strong outliers, assume normality. And then independence, you can say one doesn't affect the other, or you can say the populations are independent. And then you name the test. So this would be a 2-sample t-test. And then we go on to the formula. Okay, so this is the formula. Okay, so now you have 2 of everything as opposed to before where we just had the standard deviation over n. And the first one is for the calcium. So the problem gives you all the information that you need. So this is n, x bar, and s. That's what I get. Those numbers, I substitute them in here. So it's 5 minus negative 0.27. And when you have a minus negative, it becomes a positive. So that's why it turns into a positive. And then you put this here. And then you have the standard deviation, the sample size. Okay, so what you do is you put it in your calculator. And you go to stat test, 2-sample t-test. And then you input everything in here. And you'll get t equals 1.6. And just copy the degrees of freedom. 15.6. So you'll put calculate and it'll give you this. And then if you put draw, it'll give you the curve with the part that's shaded. And the p-value is 0.06. It doesn't give us alpha, so we use 0.05. And then just like before, if the p-value is lower than alpha, you reject the null. And if it's higher, you fail to reject. 0.06 is higher than 0.05, so we fail to reject the null. And then you write your conclusion.